Hello, my dear students. I hope everyone is enjoying their lockdown period and are safe. But I expect that they are utilizing their study time also. So, today here I am with a topic thermocouple, which is the doubt raised by my students. So, let's come to the topic. Thermocouple. So, as the name suggests, definitely it's related to temperature. So, thermocouple converts thermal energy to electrical energy. It means it is a transducer. Okay, transducer is a device which converts non-electrical quantity to electrical signals. Okay, so temperature is a non-electrical signal and it is converting to electrical signal. It is used for measuring temperature of a given substance. Okay, and it works on the principle of Seebeck effect. So what's that Seebeck effect? Seebeck effect is defined as when the temperature at the junctions of two different metals differs, then an EMF is generated, and definitely if there is a potential difference it will lead to the flow of electrons. So these are the two vessels, and here two metals are used. One is dipped in this vessel 1 and another is dipped in vessel 2. So as we have to create temperature difference, so definitely one should be an hotter body, another should be an colder one. Okay, so let's come to the construction. In this construction, here we will see that we have taken two beakers. One is consisting of hot water, another is consisting of ice water. Okay, and usually thermocouple consists of two metals, and here it is named as M1, which is a copper wire, and another is M2, which is an iron wire. Okay, and these two wires are joined, and one of the node is, or one of the junction is named as A, which is in contact with the body whose temperature is to be measured, that is T1, and another is junction is been dipped in beaker where it is a colder junction and the temperature is T2. Okay, so in this case it is clear that temperature T1 is greater than temperature T2, and T1 is the temperature which is to be measured. Okay, so in this case what happens is, as the electrons in junction A are more energized. Why is that so? Because it is a hotter body, and you know that when a substance is hot, then the electrons are more mobile enough or more energetic enough to move from one point to another point in comparison to the colder body. Okay, so here the electrons in this hotter junction are more energized, and therefore it starts moving from junction A to junction B. While moving from junction A to junction B, it is seen that it moves from copper wire. Okay, just because only one metal reacts for the unknown temperature, so that's why the electrons are moving from copper wire. It may happen that iron is more sensitive and it starts moving from iron. Okay, so it depends on, varies from metal to metal. Now this movement of electrons from junction A to junction B create holes. Okay, holes, you must have come across the term electron and holes are the positively charged. So it, while the highly charged electrons or energized electrons move from junction A to junction B, it creates a hole in the junction A, and that's why it becomes positively charged. And as the accumulation of charge occurs in junction B, so it becomes negatively charged. Okay, so since the junction A is positive charge, therefore it attracts electrons. Okay, since it is positive, so it starts attracting electron, and the return flow of electron start from junction B to junction A. Okay, this is the actual direction of flow of current. Flow of electrons means flow of current. Okay, so in this way, but you can see the number of electrons down here are more in comparison to this. Why? Because while moving from junction A to junction B, since the electrons are more highly energized, so the and mobile, so more number of electrons pass on from junction A to junction B, whereas in as the junction B is colder, so number of free electrons are less, so they move quite slowly. Okay, the number of electrons move quite slow in comparison to junction A to B. Fine. So as the electrons at junction B starts moving, it is seen that the direction of flow of current, okay, the direction of flow of current from junction A to junction B occurs from copper, and direction of flow of current from junction B to junction A flow through iron. Okay, so here our main target is to know the unknown temperature at junction A, that is T1. So how it is done? What we do is at any point we open it and replace it with a voltmeter, so that the voltmeter can measure the open circuit voltage, that is V. Okay, and it is seen that the voltmeter will show that voltage which is proportional to the temperature difference, that is T1 and T2. So V is proportional to T1 minus T2, and V is equal to S into T1 minus T2. So S is equal to S1 minus S2. So what is S1 and S2? These are the Seebeck coefficient of metal 1, that is S1, and for S2 it is Seebeck coefficient of M2. Okay, there are charts where you can follow that what is respective for the respective metals, you will get the Seebeck coefficient. Okay, so the conclusion is the generated EMF, the EMF which is generated because of the temperature difference, depends on the type of metal used. Okay, so depending on the type of the metal, the EMF will vary, as well as the temperature difference will also affect the amount of EMF generated. Okay, so usually thermocouple are classified into different types based on the type of metals. For example, I have taken thermocouple B and E. There are much more. So here the materials in thermocouple B is platinum and rhodium, and they have a temperature range of 1800 degrees centigrade. And when it comes to thermocouple E, so that material is chromale and constantan, and there the temperature range is that when this type of thermocouple is being used, so they can measure the temperature range from minus 250 degrees centigrade to 800 degrees centigrade, and the proportional amount of voltage is been shown in the voltmeter. Okay, so fine, thank you.